Hello everyone. In this video we're going to be solving a Diophantine equation. In other words, an equation with integer solutions. So we have x plus y plus 2xy equals 17, and we're going to be solving for x values. And x and y are integers. Now if you slightly change this problem and write it as x squared plus y squared plus 2xy, obviously this problem would be slightly different because on the left hand side you would have a perfect square, like x plus y quantity squared. And of course, there's no square that's equal to 17. So we would have to modify this as well, maybe change it to 16. And then from here, you can get the solutions. The problem with that, though, is there's going to be infinitely many solutions because x plus y can be 4 or negative 4. And obviously, when you change x, y is also going to change accordingly. But in our original equation, is that the case? We don't have the squares. It's not like a perfect square. It's a little different. But I just want you to, make a guess and see what happens. So do you think there's going to be infinitely many solutions or finitely many solutions, or are there any solutions at all? Because in some cases, we do not have any solutions, right? Okay, that's kind of sad because you might end up spending like 5-10 minutes on a problem and then end up with no solutions. But guess what? That's also considered solutions. Great, let's go ahead and find out what happens here. In an equation like this where x and y are linear, I'd like to have the product first. And you'll see why in a little bit that is helpful. By the way, I'm going to be presenting two solutions, and let's start with the first one. So for my first solution, I want to write 2xy first, and I want to follow that up with x. Doesn't matter, you can also continue with y, same idea, but I just prefer to have the x first. And then I'd like to factor this, but this expression is not factorable as is, but we can kind of tweak that, okay? So here's what we're going to do. First of all, we're going to pretend it's factorable by grouping and find a common factor for the first two terms, which would be x in this case, right? Would you agree? And then we would be able to take out 2y plus 1. Great. Now, here's the thing. Even though this is not factorable as is, I was able to factor part of it, and I can hopefully change the second piece so that we can have a common factor. And in this case, the expression inside the parentheses is supposed to be the common factor because it involves y, and don't ask why. And we have another y here. Good. But here's the problem. We don't have 2y plus 1, we only have y. But that's okay. You can still use 2y plus 1 as if that exists, but here's how we can do it. First of all, you have to kind of pretend that, okay, I do have a 2y plus 1, but then I kind of need to multiply this by something to get y. Well, you're not getting y from here, but you can get y plus something. So let's go ahead and multiply 2y plus 1 by 1/2. When you distribute, this is going to give you y plus 1/2. So what did I do? I added 1/2 to both sides. Do you see it? If you don't see it, then I'm just going to go ahead and distribute it and show you what it looks like. Distribute, you're going to get y plus 1/2. What was my original equation? It was this one. Now it's this one. So what's the difference? The difference is 1/2. In other words, I added 1/2 to the left-hand side, so I should also add 1/2 on the right-hand side. Make sense? So the sides are equal. Of course, it should be the case because this is an equation, not an inequality, right? Cool. Now, I'm happy because I have 2y plus 1 as a common factor, which I can take out. Let's go ahead and do it. 2y plus 1 is a common factor, and this is called factoring by grouping. So once you take that out, the second factor is formed by this plus this, because there's a plus sign. If there was a minus sign, you know what would happen, hopefully. And then this would be x plus 1/2. And the whole thing is equal to 17 plus 1/2. I don't want to leave it like that. I don't like mixed numbers. I don't know if you like them. I don't even like the word mixed numbers. Like, what do you mean by mixed numbers? Can you mix numbers? Well, you can add them. But anyways, this can be turned into 35/2. Make sense? Multiply, add, and use the same denominator. Real quick. Okay, this is fine, but it's not very good because I'm solving a Diophantine equation. I want to get integer solutions, not rational integers. So, not rational solutions. I want to get integer solutions. So, I should get rid of the 1/2. And how can you get rid of 1/2? Easy. Multiply both sides by 2. And you know what it does? It serves two purposes. It also gets rid of the 2 on the right hand side, which is good. And if we didn't have a 2 or 4 on the right hand side, we would multiply by something bigger, right? Probably, but we still have to make it work. Anyways, I'm not going to distribute the 2 here because that would give me 4y. It's not something that I'm looking for, but rather I should distribute it over here because you have a choice. So this gives you 2y plus 1 multiplied by 2 times x plus 1/2, which is 2x plus 1, equals 35. And this was my goal. Yay, I got a really nice equation. You know why? Because 2x plus 1 and 2y plus 1 are both odd numbers. Beautiful. And 35 is an odd number, which means all the factors are going to be odd numbers. Beautiful. So let's just go ahead and list them. I can start with 1 and 35. I mean, 2, 3, 4, 2, 3, 4 doesn't go, but 5 does. The other factor will be 7 in this case. And then we can switch around and write 7, 5. Or if you want, you can just come up with this and then switch the x and y values around. It's pretty much the same thing, because if you just write 7, 5, whatever you get from here, x and y will be switched here. But why double the work? Let's go ahead and just write this once, and then we'll double it at the end. Now, obviously, there's more possibilities, such as the negative ones. Let's not forget them, right? -1 and -35 and -5 and -7. Let's see what we get for x and y values from here, but don't forget to double, or maybe switch is a better word, the x and y values. So if 2y plus 1 is equal to 1, that means y is equal to 0, and the second equation or second factor gives me 17. Great. So you should also include 17 comma 0, right? And from this one, I get 2 comma 3 and 3 comma 2, of course, by switching. And this one is going to give me -1 comma -18, and of course, -18 comma -1. And then this one is going to give me -3 comma, and notice that we have the 2, 3. Let's see, 2x plus 1 is -7, -8, -4. Okay, it didn't give me a 2. I was expecting to get something like this, but anyways, that's okay. There should be a total of 8 solutions. Because 35 is odd, you know, it's kind of like a weird number, right? We only get these. Great. Let's go ahead and talk about the second method, shall we? Okay. For my second method, I thought about this, and I think this should make sense. And obviously, as an alternative to the first method, or maybe 1b, you could also do this. You can multiply both sides by 2 first, and then factor out an x, and it would hopefully work. Okay, just slight variation, you could do that. All right, great. So for my second method, I want to isolate one of the variables and write the other one in terms of the first variable. So why don't we just, since we have the two y terms, I want to go ahead and factor out y. It's going to give me 1 plus 2x plus x equals 17. Great. Let's go ahead and subtract x from both sides and then divide by 1 plus 2x. I hope that wasn't too quick. I did 2 operations in once, but that's what it is. Subtract this and divide by 1 plus 2x, okay? Now, let's go ahead and simplify this, because this doesn't make that much sense, right? I mean, how can you use this information? I know x is an integer, but I don't know if this is going to be helpful. But let's go ahead and write it this way first. This is more friendly. Now, at this point, you could probably do the following. Try to break the top down into something like this. Negative x minus 1/2. Let me think about it. Plus 35 halves. You see, it's bringing us to the same number. And then kind of do it like this. You know why? Let me tell you. When I did this, actually, these two will have a common factor. In other words, the numerator will be divisible by the denominator. It's actually the other way around, but you get the idea. So now I can do the following. I can kind of take out a -1 first to get rid of the negativity. And then this one, I can pull out a 2. That'll be x plus 1/2. And then now I'm separating this. That's going to give me 35 over 2 times that, which is 4x plus 2. Great. So now these two cancel out, leaving us with -1/2. But guess what the problem is? We still have a 1/2 in this situation. So at this point, we should multiply both sides by 2. That's going to give us 2y equals -1 plus, and you can just kind of simplify this by 2, because 2 is going to cancel out. 35 divided by 2x plus 1. And guess what? This is going to bring you to the exact same point, because in order for this to be an integer, first of all, 2y needs to be even. And then this needs to be a divisor of 35. So when I add -1, it should be even. And you're going to go through the same thing, exact same things. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, Be safe, take care, and bye bye.